Hi, good morning or good afternoon, depending on where you are. Very pleased to be with you again after our delayed start last week, or our missed start, I should say, from last week. I'm very pleased to have Kevin Humanek here today as our presenter. Just a little bit of info on Kevin. Kevin is the National Sector Leader for Science and Technology at Architecture 49. He's a design architect, having obtained his master's degree in architecture from the University of Manitoba in 2000. He's a registered member of a variety of provincial architectural associations, as well as the Royal Architectural Institute of Canada. Kevin's a proud board member for Sustainable Labs Canada and is a lead accredited professional. Over his 14 years in architectural practice, Kevin has gained considerable experience in a wide variety of roles and responsibilities. He's been a project manager and a design team member responsible for client liaison, functional programming, laboratory planning, and architectural production work on a variety of science projects. For the past 10 years, Kevin's been exclusively involved in research laboratory projects as a project manager, project architect, and laboratory planner. Kevin's presented at various conferences and seminars, including at Tradelines, the RPIC National Workshop, Sustainable Labs Canada, and previously at the Canadian Biosafety Symposium. Kevin is going to do a presentation today for us on integrated design principles for lab projects. I would just ask if anyone has any questions throughout his presentation that you please just type them in the box on your screen, and we will certainly get to all the questions at the end of Kevin's presentation. Without further ado, it's my pleasure to introduce Kevin, and it's all yours.
Thanks very much, Martin. And good morning, good afternoon to everybody. Thanks for attending. I'm honored to present. This is actually an encore presentation of a presentation that I gave at the last conference for SLCan, which was held here in Winnipeg in, I guess it was late October of 2018. And so the thought was that I could present this again in webinar format for anybody within the membership that may have missed the presentation. So happy to do that, and very happy to take any sort of questions that might come about at the end of the presentation. It's about 45 slides, and I'll take you through it. It's basically gleaned from lessons learned and concepts kind of delivered through numerous science projects that I've worked on over the last decade to 15 years. So without further ado, I'll launch into it, and if there's any questions, I'd be happy to take them at the end. So the objective of the presentation was really to put forward an integrated design approach and specific strategies which can be used by lab project delivery teams in order to ensure alignment around critical lab design principles. What does that mean? I had a full abstract written, and these are kind of the bullet points from that, and essentially a breakdown of my presentation. But we really wanted to touch on the stakeholders and decision makers that interface with science projects, whether it's a retrofit or a brand new building or just a systems replacement project. We're often dealing with a broad and diverse set of stakeholders. So really wanted to touch on that with the group. We want to talk a little bit about some specific strategies that could be used by specifically lab project teams in order to bring alignment around lab design principles. I want to talk a little bit about the formal and informal modes of interaction that take place during project delivery, a little bit about the roles and responsibilities, some principles and rules of engagement around that, some specific examples, as I mentioned, from my past project work and the past project work of the firm that I work within, Architecture 49. I can talk a little bit about industry tools, and then also about project delivery models and the fact that we're dealing now with a diverse set of modes of construction, whether it's design, build, finance, maintain, or public-private partnerships, or even just construction management type delivery models. There's no singular way of having construction delivered and projects built out. So that's a complexity that sometimes we have to deal with within lab projects. So I'm a big fan of some of the quotes from Tom Peters. So this is one that I looked up in the context of this presentation, and I was joking at the conference in October that when I looked up the word panacea, I was gratified because the word panacea actually means a solution or remedy for all difficulties or diseases. So I was thinking it in the context of difficulties and overcoming them, but actually it's includes diseases. So I thought that was interesting in the context of science and some of our research and diagnostic projects. But communication is what it's all about. Moving projects forward, the tools and the outcome are always geared around communicating ideas and approaches to getting from point A to point B. And we can't do that effectively without proper communication by the team. One of the things that always astounds me is the number of stakeholders and decision makers that can sometimes come to bear on a project. And this is just an example of one set of project team stakeholders. The project team is sometimes a relative term. Project teams can sometimes be considered just the consultant team together with the client representatives who are involved in project management or in project review. But stakeholders and decision makers on projects can often include groups such as the general public or the authorities having jurisdiction if they can be effectively brought on board early. Oftentimes, institutional clients have occupational health and safety departments that need to be actively involved in the development of the project so that you don't have hurdles at the end or during construction where your design is not aligned with the occupational health and safety mandates of the institution that you're designing the project for. Oftentimes, funding or grant organizations can play a role and have a bit of a veto power. So it's often important to have them on side and part of the project team itself. Community liaison groups becomes very important when you're dealing with a project that's of public concern or could be seen as requiring community liaison. Discussion and communication with the surrounding communities or regions or municipal environment that you're dealing with becomes important when there can be backlash or it can impact the delivery of the project or the construction. I touch on regulatory bodies, so that includes not just authorities having jurisdiction, but if you're dealing with a project that requires regulatory compliance, such as the Canadian Council on Animal Care or the compliance with the Canadian biosafety standards and guidelines, there is a requirement for discussion and interface with those regulatory bodies to make sure that you are in compliance so that you don't end up with an issue at the end. Biosafety representatives are bound in some cases, occupational health and safety, and scientific administrative groups are often integral parts of not just the user team, but the project team as a whole, and can be embedded in the project team. Facility management groups are also a set of groups on institutional and governmental projects where they have very specific requirements for material flow, waste flow, personnel flow within their facilities. And if not consulted properly or effectively, you can get it wrong. So it's something that I often bring up in project kickoff teams meetings so that we can make sure that FM individuals are at the table early. The last bubble here was institutional private client management teams. So oftentimes when we're dealing with science projects, the client or institution has a broad-based management team that has to be actively consulted. So this is just a series of elements that I think oftentimes are included in the overall makeup of the project team, but we can also run into situations where one or more of these elements are not considered. And so we often, at the kickoff meeting or when we start the project, bring that to light so that we can make sure that we bring those people into the fold. This is just a graphic that I inserted into the presentation just to remind myself that people communicate in different ways, and the media through which we communicate nowadays is becoming varied. What we're doing today in the forms of a WebEx or webinar is just a perfect example of a different mode of integrating and communicating. So a lot of web-based technology is being used nowadays, as well as traditional physical means of producing documentation and materials for communicating with project teams. Cell phones, megaphones, other technology methods, but we still, as architects and engineers, often use physical means such as drawings, models, specification booklets, reports, and other media that are more, let's call it traditional, but very much you can see in the industry the use of virtual reality, online web graphics, online presentations, and other forms of communication flow so that people have different ways of consuming project materials and understanding the project as it evolves. This next slide is specifically about project consultant team complexity. I took a page out of the Royal Architectural Institute of Canada's standard contract for services, and this is specifically used to hire project teams for the delivery of design of a project. And you can see that there's several different types of services that could be layered on to a prime consulting contract, and some of them are on the screen, and I won't list them all off. You can see them. One of the, this is in addition or above and beyond the hiring of just an architect or a prime consultant or a chief design group. There are various sub-consultant roles and specialty sub-consultant roles that are often filled by a myriad of different firms or individuals within firms. So the project consultant team can be very complex. And I always laugh, the one item here, 1.25, is left blank. So then literally if this doesn't fill the check every box, you have the ability to add a sub-consultant or a specialty consultant that isn't listed here. So the list goes on, and actually you can see that there's a few more that didn't fit on the first page. So what this speaks to is the complexity of our project teams and the need for effective communication. It's just a graphic means of representing that. And it's also a reminder that prime consultants are not necessarily Renaissance men or women. It's not the idea that a singular group or a singular individual can deliver a project to success is a myth and not a reality in today's modern environment, and the complexities of the projects that we deal with when it comes to science, whether it's research, diagnostics, institutional, manufacturing, science projects require a broad team and a range of services and expertise. So some specific strategies which can be used by the teams, here on the screen. So, traditionally, I've always found in the last 20 years of my work that meetings and workshops really have to be effectively planned and strategically used in order to move the project forward. There's no substitute necessarily for face-to-face meetings. And, we often consider separate meeting streams for management or project management discussions, separate from consultant team meetings. So that's here on the screen. The reason for that is that client teams although they might be interested in the day-to-day consultant processes, need to be able to talk about project management matters, issues of scope, schedule, and fee, matters separate from a broader consultant team. And conversely, consultants often need private time within the consultant team led by the prime consultant to be able to hash out sometimes circular issues of coordination or putting together concepts that would then be presented to the client team. So oftentimes the consultants need their own venue to hash things out, and it sometimes isn't a pretty thing. So you can do that separately from the eyes and ears of your client management process. We also advocate for technical meetings where specific technical coordination issues can be resolved between engineers, between architects and engineers, between landscape architects and civil engineers, and the list goes on and on. So separate technical sessions often need to be kind of conceptualized depending on the size of the project as a separate thing. And the other one is the concept of discussions around biosafety and facility management. So those are focused discussions, and selectively you can include members of the client team and the consultant team in those discussions so that requirements around biosafety and facility management can percolate to the top. Otherwise, oftentimes biosafety experts or biosafety officers within the organizations or the FM people can sometimes feel marginalized or not able to speak because other, let's say it more kind of global or holistic issues are being discussed in the meeting. So you need to give them a bit of space. Those are some of the subsets that we typically organize. Steering committee sessions and integrated design process sessions are really important, where you bring everybody together to talk globally about the project. And we sometimes use the term the 3 E's, the idea of having the 3 E's involved. It's everyone and everything early. So the idea of having global visioning or integrated design process meetings early in the development of our projects often leads to the group having a common understanding of the project, and then you devolve into separate meetings and workshops afterwards. But we also, whether you're doing functional programming with a multi-department science group or science team, or if you're dealing with a research group or diagnostics group with multiple sub-departments, we often have to have a wide variety of user groups and science stakeholder sessions. So those become more kind of focused and breakout, separate from kind of more integrated group discussions. So you have to be able to, in order to kind of understand specific project requirements, you need to have large group sessions, and then you have to be able to kind of tone those down in terms of size and breadth so that you can focus on specific subtasks or sub-needs. Within that, there's an above and beyond kind of face-to-face or web-based meeting platforms. There are site reviews and assessments that are often critical parts of moving projects forward. And the reporting comes out in a wide variety of forms, and I often talk about the wide variety of deliverables that are produced by project teams are often in report format, whether it's a geotechnical report, or if it's a traffic and wayfinding report, or if there's a series of building condition reports, we end up oftentimes having to have an organizational structure for organizing reports and sub-reports for our clients, so that information is easily found and is also dated, so that we can understand the evolution of project information. Emails are the bane of many people's existence, so the idea of being able to communicate through email is essential in today's time and place. But being able to capture emails in a regularized format or a maneuverable format so that they can be articled is critical, and then documenting critical emails in the form of reports often becomes required. At the bottom of the list is the idea of communicating through drawing packages and specifications. So ultimately, architects and engineers issue projects for tender with a combination of drawing packages and specifications. So that the specifications supplement with information and specific instructions around the building systems, and drawings help the contractor and the client team to understand overall configuration and layout. So these are all specific strategies to bring alignment, and the drawing packages and specifications can be reviewed at successive milestone delivery points before tender so that everybody's on the same page and refinements can be made. So this is just a graphic around trying to solve problems and how you know, the communication flow around problem solution can take place. And you know, that's why you know, a number of communication events need to take place, and structured meetings need to be put forward on the project plan so that you can move through the problem evolution cycle as a project team, not in isolation of one another. So this is just a graphic that we sometimes use to show that it's not enough just to identify the problem and then implement a solution, that there actually has to be an evaluation step, which is often step 3 and step 4 and 5, where you're actually coming up with a way of solving the problem that's mutually agreeable to the team. You can't just implement a solution that may not be acceptable to the broader team, or that may have extraneous impacts to other elements of the design. This is a graphic just to show that a mapping has to take place on a project-by-project basis in terms of the stakeholders. So back to the concept of mapping out your stakeholders on a project-by-project basis. So this was put forward for a project at Memorial University in the East Coast in St. John's, Newfoundland. And so we mapped out a variety of groups of stakeholders. So this is just a graphic to show how sometimes a mapping exercise has to take place at the beginning of the project to understand, okay, who are we dealing with in terms of, let's call it client stakeholder groups, community stakeholder groups, and also perhaps regional stakeholder groups. So it's not enough to just say, oh, well, we've talked to the end users and everything should be fine. If you're looking at more broad-based impact or considerations for the project, and if your project is large enough that it has impact to the region or to the community around it, then you have to be thinking broader than just the end users. So then this is another graphic example of how we sometimes look at meeting scheduling so that we can make sure that in a focused amount of time we're hitting a number of different stakeholder groups and organizing meetings in a very structured way. So we laugh sometimes that we have to consult in order to consult. So we consult on the methodology of how we'll eventually consult. So there has to be a plan on how you actually communicate. And sometimes that evolves into a Gantt chart. So this is an example of a Gantt chart where we're mapping out a series of individual work streams and breakout sessions along the top that's overlaid over top of the design process, which is in the middle of the diagram. So the idea that we would have regularized steering committee meetings, regularized project management meetings, focused technical sessions, design sessions for the evolution of the architectural and engineering design, and then integrated design process sessions so that we have periodic integrated sessions with all stakeholders so that everybody's consulted somewhat regularly. Sometimes it's every 3 months on a project, sometimes it's every 2 months on a project. The cadence of these meetings have to be thought out so that you're communicating effectively at each stage of the project. And you can see from this diagram as well that the cadence of some of your communication elements at the top in your work streams, they change from project phase to project phase. So once we've evolved through early design and you've set the overall project design at the end of design development stage, usually as the consultant team works through detailed construction documents, which are the construction drawings and specifications, the communication frequency or the intensity loosens slightly because you're working through the details. Early on in the development of pre-design, schematic design, and design development, the cadence is by necessity more intense because you are solving the overall global holistic issues and you're not down in the minute details of the construction details. So you can see that graphically just at the top of the screen. One of the specific strategies that we like to use is a look-ahead schedule, which is sometimes a 3 or 4 month look-ahead schedule. And this is just an example. But people are graphic or visual in their comprehension, and they can absorb information. I know myself included, a lot easier if it's in a visual format rather than a written format. So we sometimes use graphic look-ahead schedules to map out upcoming sessions so that everybody on the team can print it out, keep it at their workstation or at their desk or up on their fridge and know, okay, I'm going to see the team next week, and after that, it won't be for another 2 weeks after that, or I know where I need to be and when. Another thing that we do is to map out communication frameworks in chart format. So we talk about the communication event or goal, who needs to be involved, the frequency of those communications, what tools and techniques we're going to use, and what's the benefit, why are we doing it, what are we achieving. So it's a bit of a process map in chart format to explain to ourselves and communicate to other stakeholders what the framework of communication is. So this is important, and we often do this for our medium and large scale mandates. When you have to understand that on a small mandate where you're developing a feasibility study for a single user department, this becomes untenable and unrealistic. So these are communication frameworks and tools that have to be scalable. Regarding roles, the communication process and the delivery of projects requires not just a singular individual, and usually not a singular type of working through the solutions or roles. Sometimes we need people to play multiple roles, but oftentimes teams need to involve individual people to play specific roles. So decision makers, conceptual thinkers, that's two different modes of working through the project. Ultimately, you do need a senior buy-in on your projects, and a determination has to be made at what level key decisions will be made. You need conceptual thinkers to think outside of the box in terms of bringing new ideas and how to solve problems, which instead of just taking a cookie cutter approach to solving problems, we need to be able to conceptualize new ways or creative ways to solve problems. You use the term critical calculators. Sometimes those are our technical staff. Sometimes that's a special engineer that's brought on team to be able to bring together a myriad of different information to calculate solution sets. Synthesizers can bring together information from multiple project team members and synthesize them into the best way forward. Sometimes that requires a decision-making matrix in terms of rating and ranking what's most important, and we sometimes refer to our project charter and goals so that we can make informed decisions around different success criteria or key performance indicators. We need measurers and people who can be able to quantify things. We need quality assurance and quality control roles on your team. Even if it's people who are already on your team, we need to be able to make sure that there's a step before deliverables go out the door or get issued to the construction industry that you've done your best to make sure quality control has been taken care of. And even before that, you need peer review so that people can come at your project with a completely fresh set of eyes and look at it without any sort of bias, to be able to question and troubleshoot why you've arrived at the solutions that you have. And you need constructors or contractors to make it a reality. This is the slide I referenced earlier in my presentation, which talks about the myriad of different types of reporting that takes place. I've used this slide in some project team meetings where we've talked to client teams about the different sources or sorts of documentation that we can sometimes receive as a project team, and other times be asked to help deliver as a project team. So oftentimes some of this work we call the enabling work, whether it's a functional programming report or a master planning document or a set of building condition analyses. This is a reference list of some of the important documentation that you need in hand when you start schematic design on a project. And some of these things, such as life cycle cost analysis, risk analysis report, options analysis report, are often documents that project teams do perform or deliver as part of their pre-design or schematic design role, depending on your mandate with the client and what the contract requires. This is just, to reference a couple of the recent projects that I've worked on. This is a project from about 10 years ago for the Public Health Agency of Canada here in Winnipeg. This was a complete retrofit of the Ward Lab, an existing material testing lab that was privately and at different times provincially aligned to do geological and material test analysis. But it was purchased by the federal government and through Public Works converted for use by the Public Health Agency of Canada as a microbiology lab for HIV. So it was the function of the building was completely changing from that of an analytical chemistry lab with 150 fume hoods inside of it to become a complete change to a microbiology lab. So there was a huge amount of work done to assess the existing building systems, and the judgment was made to rip out a good portion of the existing operational systems within the building, whether it's all of the electrical systems, all of the mechanical HVAC and plumbing systems were removed, and the exterior facade was completely removed and replaced with new high performance building envelope. So this project required the integration of 16 separate task groups, which then rolled into 8 user groups. But there were a variety of different science principal investigators within the building, as well as meeting with biosafety, facilities management, and administrative staff key stakeholders in order to kind of evolve the functional program and to do fit analysis so we could fit the program within the existing footprint of the building. So there was a target to maintain the existing 60,000 square foot building footprint and not expand beyond that. So we did a lot of work through conceptual design, pre-design, and schematic design to do fit analysis so that we could ensure that we could fit the programs and the programmatic needs within the building, and then zone the building effectively to deliver kind of high performance microbiology space for the Public Health Agency of Canada. Within it, there was an evolution towards open concept planning, but this image I like because it talks to the coordination, even in a retrofit project, of dozens of different types of systems, whether it's the flooring system, the lighting system, the structural system. You can see fire protection piping in the exposed ceilings to the right. You can also see suspended ceiling systems to the left, plumbing and lab casework systems, as well as equipment systems. Another feature of the building was the addition of exterior glazing so that we could bring more natural light into a very deep building. So the concept of zoning work areas so that, the areas where people were spending most of their day were areas that were against the exterior of the building, as opposed to core support functions and support labs zoned towards the center of the building away from the windows. So you were giving priority to the use of space where people were actually going to be and getting natural light to those people. This is a project that was delivered for the National Institutes of Health in the US, called the Rocky Mountain Lab. So this project was an amalgam of, I believe, 10 different user departments for a combination of containment level 2 and containment level 3 and containment level 4 program. So the zoning of high containment, the zoning of security, so that you were achieving a high containment solution which was also secure and safe, but also, again, looking to natural daylight and views and reconciling how to combine programs within the building requires a huge amount of coordination and discussion around the design process. And this image is from the HEPA filtration deck and the air handling system mechanical penthouse, where a lot of the support systems above the labs were coordinated. So it's a reminder of the complexity of the project and the need for coordination, which is often done now through building information modeling and clash detection. Just another image, this one from a concept design for a project in Eastern Canada. We're talking about the concept of real-time analytics on the projects and the idea that partitions can be used for information display, as well as to promote science on display between office areas and lab areas. So this is a concept that you can see is telling us that the idea of integrated design and cross-departmental communication is something that our clients are looking for, and that contributes to long-term success of the end solution, because we end up with flexible work areas with removable walls between departments so that you can have long-term flexibility. And it allows for retrofit of these facilities at a later date, so that the solution is malleable, and sometimes we use the word expandable. This project is competition entry for the Canadian High Arctic Research Station, which was put forward by our firm and a number of other partners, including KPMB, for the Canadian High Arctic Research Station in Cambridge Bay. Ultimately, this was not built, but the concept here revolved around a huge amount of soul searching around how to design for the Canadian Arctic and how we would be able to achieve the construction of the building within 2 construction seasons. And the fact that Cambridge Bay is only accessible by barge or boat for 2 months of the year. So the concept that was put forward for this project was a multidisciplinary concept about how to create a building within a building. And what was put forward in this solution, which we were pretty proud of, is the idea of a aerodynamic building shell that would be built in the first construction season, which would then be heated and enclosed, allowing for prefabricated lab components that were fabricated in southern Canada to be shipped to site for the second building season. So the idea that your solution is a multidisciplinary integrated solution that is reached not just by an architect sitting alone at their desk coming up with a good idea. It's the idea of layering good ideas on top of one another so that you can reach a truly innovative solution. This project is a project that our firm is working on right now for Trinidad and Tobago. It's a National Public Health Labs for Trinidad and Tobago, as well as the Caribbean Public Health Agency's diagnostic facilities for that region of the West Indies. So this project is specifically involving 3 major stakeholders, which includes the National Blood Transfusion Service of Trinidad and Tobago, but it also involves a subset of 8 user groups and a variety of other governmental and facility stakeholders. So a lot of process evolution, a lot of discussion about the zoning of building systems, and access to natural daylight and views was critical to the development of the project through functional programming and design brief verification, and then leading on into kind of more detailed traditional schematic design and design development. This project is in excess of 100,000 square feet on 3 levels. Another project, which is in excess of 350 to 400,000 square feet, is the Edmonton Lab Hub, which is currently under design and now into construction for groundbreaking and for foundation work, is under construction in Edmonton. This project specifically deals with 16 major user groups, but 48 subgroups. And so a huge programmatic and program verification team was required in order to vet the program and to develop the master program for the project. And then a team of dozens of consultant team members evolved the conceptual design with heavy integration of stakeholders from the provincial government and from private stakeholders to develop the overall conceptual building envelope. So the idea that you see on the screen is the idea of a high throughput analytical, what we call the ballroom or core lab, as a single-story building adjacent to a multi-story, 4-story lab block with what we called an interstitium or connective tissue leading to an office block. So the idea of zoning high-intensity labs next to more traditional wet labs in a vertical format next to support administrative functions and office space. So the idea of building purpose-built space, but also adaptable space. So the office block in this case was designed so that it could be converted to labs at a future date. And that's all agreed upon and evolved through specific interaction with the client team. We do protocol mapping through most of our high containment projects. And so this is an example of communication flow around process. So we not only do we do a layout for the specific labs that we design, and we tag the different components and pieces of that lab architecturally, but we map the process of how you would enter or exit that space through a series of acronyms and abbreviations. We would map how you would enter that space and how you would exit that space through a protocol map. And oftentimes our clients use these maps for their standard operating procedures. So it's a bit of an additive service that we don't always do, but it's a way of communicating with the client team and to provide clarity and a deliverable that ultimately isn't just about building design, it's also used during operations of the building for years to come. So moving along, just wanted to talk a little bit more about the communication process. This slide talks a little bit about how the methodology of communication tools and the types of tools that you use during early design phase actually evolve during late design phase and construction. So you can see the tools and communication tools that are listed on the left move from more kind of traditional design functionality specifically over to more let's call it functionally specific documentation during design and construction, because we're ultimately telling the contractor exactly what to build and how much and and where. So we have to be very specific. So we're talking about detailed construction specifications, full building schematics, and then at the end of construction, recording as-built documentation and record drawings, and the final commissioning reports to confirm that the building or the building addition or the building retrofit works and is commissioned to work exactly as per design. And that includes post-occupancy analysis, such as measurement and verification studies, to make sure that operationally you're in alignment with the design criteria. We sometimes talk about lean planning and process mapping. So this is just a slide to talk about the fact that mapping flows within the projects is sometimes a very complex thing, but lean planning and some of the concepts that have come from healthcare design are making their way into lab design, so that we can talk about if there are repetitive processes, whether they're research process, but more often diagnostic processes, we could map those out and design a building that is specifically laid out to enable efficiency in the work that the people do within that building, and also look at not just sample flows or personnel flows, but how we're handling things like media prep, glass wash functionality, how we're making security and biosecurity a process that gets overlaid or is considered during building layout, and then we're ensuring that safety and biosafety is also considered through the process flows. So sometimes we use post-it notes like this as an example, just to talk about process mapping, as well as we do this in terms of layouts over top, in terms of functional layouts, getting the end users or stakeholders involved in specifically being part of the project presentation team, so that they're walking through the layout of their labs by putting post-its and actually getting up and interacting with the floor plans is a great way of having people take ownership of the solution, so that they can say, this is my lab, as opposed to, here's the lab that the design team delivered for me. They become an active author and participant in the process. When we talk about sustainability and communication around sustainability, we constantly remind ourselves that engineered systems is some technology that we sometimes try to deliver at the end of trying to think about low-tech or no-tech solutions. So building orientation, the minimizing of engineering needs by understanding how we can kind of configure the building or lay the building out in an efficient way and take advantage of more passive solutions before we start automatically going to the 20% of the high engineering solutions. And these are concepts that we've heard from at SLCan presentations from people like Gordon Sharp and others. This is a project management process map that I had included in the slideshow just to scare people, but it was meant to talk about the fact that from a project management book of knowledge, the project management process map is very complex, and on a very large project, you are dealing with a variety of different elements of project management that can sometimes take away from the communication process, or at different times can enable the communication process. So it was just meant as a speaking point. One of the other things we wanted to touch on is in terms of communication, and I did allude to it earlier in my presentation. We're almost through here, but wanted to to bring up again the importance of new computational tools and the importance of building information modeling in today's project delivery process. So the idea that through digital and cloud-based technology, we can communicate design and coordination through the web, through cloud-based technologies such as Revit and BIM 360, so that projects can be developed in real time with multiple stakeholders impacting and interfacing with the model to deliver an integrated solution and communicate that solution in different ways. So, this is a process wheel that we talk about, the fact that sustainability and integrated design process involves strategic and tactical delivery, and we move from planning processes early on in the project through design processes through to operations, and the fact that communications have to be key and thought about not just for early planning, but for all the way through the project life cycle as well as the building life cycle. the projects are complex and require a huge amount of integration, and that becomes evident when the building goes into construction. So at this point, I didn't want to go too much further. There's a couple more slides that deal with P3 and design, build, finance, maintain methodologies. But in order to allow a little bit of time for questions and answers, I wanted to kind of maybe wrap up here today. And if people wanted to circle back to me, I'd be happy to kind of take any questions that might have been submitted through the questions dialog box. And I'll also put my email address up on the screen here so that if anybody has any specific questions you'd like to follow up directly with me offline, I'll put that up for you. So Martin, at this point, 10 minutes to the hour, be happy to kind of take any questions that people might have about what I've presented.
Okay, great. Appreciate it, Kevin. I guess the first thing that pops into my head is how the heck do you ever get anything done?
That was the first question I got when I presented in October. But I guess I don't mean to scare people in the presentation, but it is something that, you know, there is complexity there. And I often am amazed and humbled when projects are ultimately constructed, because the construction process and the idea of moving something from an idea through to a tactical reality is something that requires so much communication. It requires so many little discussions. And I often think about, you know, every little meeting counting towards the ultimate delivery of a successful project. But you think also about what happens on site during construction is also another corollary to it. The idea that how many little on-site discussions lead to a contractor being able to successfully build a lab and deliver it such that it meets the performance criteria. It's about discussion and about getting ideas from one person to the other, from one person's head into another person's head, and also leading to consensus. So that's a slide that, you know, that speaks to it. It's another quote from Tom Peters. I'm not sure, you know, if that answers your question, but it is a bit of a miracle when projects are delivered in my mind.
Yeah, I just related to a bathroom renovation I'm trying to do right now with my wife, and I can't imagine, you know, trying to do something to scale of which you do it. But there are no further questions, I guess, at this point, Kevin. So I guess we can let you go. But I just want to say thanks very much for the presentation, and it was very interesting, and it must be very rewarding for you when you actually get to that stage where you're walking in a building that you've gone through all these hoops to get to.
Absolutely, yeah. It's been what keeps me going is the variety of the projects, and the types of science that get delivered through the projects are never the same. There's no singular way of delivering these projects, and ultimately the projects that are delivered in the Canadian context for science and technology, there's no cookie cutter project type. There's always a different way of delivering the science, or there's a different, let's call it, combination of project mandates, so that we're never dealing with the same project twice. It's always a unique problem that you're solving, or it's a unique process that you're trying to house, or it's a group that's trying to do something that maybe hasn't been done at all ever before. So you're trying to put brackets around something. So it constantly reminds us to keep an open mind. But what I've tried to put forward today is that you can achieve communication by active listening and by trying to be inclusive in the process. It's really about making sure that you're asking the question as early as possible: who needs to be at the table, and how can I reach them, and what's the proper way to integrate them into the process with agreement from the client and the senior stakeholders. So it's a bit of a four-dimensional puzzle that you're trying to solve. And ultimately, if you've solved the communication puzzle, then I think that success is much more likely, not guaranteed, but much more likely.
Mm-hmm.
So
Well,
that would
it's
be the
actually sound advice for, not just designing a building. It's sound advice just for management in general. The
I think
consensus
so.
building is always yields better decisions and
Right.
decisions that people buy into.
Absolutely, and that's I think the where I've taken this presentation from is because my role has kind of evolved over time to be more of the project manager, on the side of the project team, and so what I've tried to put forward today is reflective of more project management, than, let's call it, traditional architectural approach, we're trying to advocate here for the value of sound project management, sound architectural project team leadership, but also effective communication. So that's where I've come from. If there's any other questions, be happy to answer them by email or.
There is a question here.
Mhm.
Do you have any recommendations on what is the best method or efficient method to prepare the meeting minutes when a large number of stakeholders are involved?
Mm. Well, typically what we try to do is structure, if it's an integrated session, try to structure it in terms of a very focused agenda and try to hold to that agenda. If there's a way of setting the agenda such that you can roll the agenda directly into the meeting minutes, it becomes more efficient. So then you can actually take your agenda and expand it to basically directly into writing the meeting minutes. And we try to make the meeting minutes very focused, not on a narrative description of exactly what was said, but try to summarize key topics discussed. And as well as, it's as anybody who's ever had to read minutes will tell you, it's always better if you can focus on actionable items. So that's also really important. Ultimately, if it's an IDP session, it does get very difficult to try to reflect everything that was discussed. So sometimes what we do is we record them, video and or audio recordings, so that 5 years later, if somebody wants to understand what it was like to attend that first visioning session, you actually have it recorded. So there's a few tools, but don't try to, my advice would be to not try to document every word that was said, but to use an editorial process to make sure that you're capturing the actionable items and the general outcomes. And ultimately visioning and IDP sessions, especially the first one, a major deliverable out of them is a project charter. So understanding from a high level what is the project success criteria, what is more important than others, what percolates to the top of the list, because later your project charter can be used to make important decisions about path or options. If construction schedule is the most important thing and cost is less important, then you might make decisions during design that emphasize the importance of delivering the project in a timely fashion at the expense of cost. But conversely, if it's inverted, then you may make completely different decisions. So it's about priorities and prioritizing things. And I guess from a sustainability perspective too, is what are your sustainability strategies and or goals? If you can be specific at the early stages of the project about what your targets are, then you're much more likely to achieve them.
Mm-hmm. Great. Well, I see we're just about out of time, so I guess we'll let you go at this point, Kevin, and again, thank you very much.
Thanks, everybody, and thank you, Martin.
Okay,
have a great
bye
day.
now. You too. Bye now.